All right, this is going to be the first video for Note 75. I'm going to break it up into two parts. So question number one is going to get its own video. It is a quadratic word problem. And I did put an asterisk in front of this mess because this is definitely going to be a problem you're going to want a calculator for. All right, so at some point I'll split screen with the calculator. But I give you a formula. So we've got h is equal to negative 16t squared plus 48t plus 160. So nicely. It's in standard form. That gives the height of an object thrown from a building 160 feet high with initial speed of 48 feet per second, where t is measured in seconds. Find the time for the object to hit the ground and find the maximum height of the object. So there's two different questions I'm asking for here. So I want a time, and then I want a max height. All right. So let's talk time. And specifically, I want the time for the object to hit the ground. So remember, this is this h is the height of an object. Well, if the object is hitting the ground, the height is nothing. The height's 0. So what I'm going to do is take this equation, and where I have h, this height, I'm going to make it 0. All right, so 0 is equal to negative 16t squared plus 48t plus 160. And I'm not a huge fan of that equation. All right, not in terms of like it's a bad equation, but just there's some big numbers going on. So what I'm going to do is I am going to try, and I'm pretty sure it works, but I'm going to go ahead and divide everything by negative 16. So let me go ahead and grab a calculator. That is not a calculator. That's going to be there's a calculator. All right, 0 divided by negative 16. That I already know is 0. Negative 16 divided by negative 16, I know that's 1. So that's going to be t squared. But how about 48 divided by 16, make it negative? That's negative 3, so minus 3t. And then 160 divided by 16, make it negative. That's going to be minus 10. All right. So now I have a quadratic, but the nice part is this quadratic is factorable. So what multiplies to negative 10 and adds up to negative 3? I'm liking 5 and 2 for that. Let's go ahead. If I make the 5 negative, let's see. Negative 5 times 2 is negative 10. Negative 5 plus 2 is negative 3. Those are the right factors then. And then I'm going to take each factor and, of course, set it equal to 0. And so I'm going to get t is equal to 5 and t is equal to negative 2. Let me make that calculator disappear. Okay, so one of these is the time when the object hits the ground. The other one makes no sense. So t is equal to 5. Yeah, that makes sense, right? You throw an object. It, falls through the air, gravity, whatever, all the things. 5 seconds later, hits the ground. Awesome. You throw an object, blah, 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 hits the ground 2 seconds before you threw it. And I have a big question mark next to my, what I'm saying it. So this implies the idea of time travel, which, no, we're not going to do that. So no, this answer does not work. There's one answer for the final answer here, and that's going to be, I'm going to go ahead and slide on over to time here. There we go. So this is 5, and it's measured in seconds, so seconds. So for the time for the object to hit the ground, 5 seconds. Now there's a secondary part here, which says I want you to find me the maximum height of the object. So we're going to do this in 2 parts. Actually, the first part here is I'm going to go ahead and slide this whole thing over. There we go. And then when I want to find the maximum height of the object, what I need to find is the vertex. So the first thing I need to find is the x value, or in this case, the t value of the vertex. So that's going to be t is equal to the opposite of b over 2a. So in our equation, 48 is b, so the opposite would be negative 48 over 2 times negative 16. So negative 48 over negative 32. Let me see if I can grab, there's the calculator back. All right, so make 48 negative divided by 32 negative. All right, that's going to be 1.5. Go away. There we go. All right. So t is equal to 1.5, which basically tells me that for our vertex, for, in this case, the maximum height, the time to get to the maximum height is 1.5 seconds. So you're standing at the top of the building, you throw that object 1.5 seconds after you throw it, that object is at its maximum height. Now, what maximum height? Haven't figured that part out yet. But what I am going to do is take this 1.5 and put it in the calculator. Well, actually, I'm going to put in the equation first, then I'll deal with the calculator part of it to figure out my height. Remember, because h is our height, and these t's are specific times to get to those heights. All right, so let's go ahead and do a little substitution here. So h is equal to, h is equal to negative 16. Everywhere I have a t, I'm going to replace it with a 1.5. So t squared plus 48t, again 1.5, and then plus 160. All right. Now, not a huge fan of the calculator here. I'm going to do this in kind of parts. So 1.5 times 1.5. So 2.25. I'm going to go ahead and multiply that times a negative 16. All right, so that is going to be, whoops, right with a pen. Negative 36. And then if I do 48 times 1.5, that's 72. And then I'll go ahead and add everything up. So 36, make it negative, plus 72, and then plus 160. All right, that is a height of 196. Make the calculator disappear again. So find the maximum height of the object, and our height is in feet. All right, so after all this work, we figured out the maximum height is 196 feet. All right, so with these questions, make sure, I'm trying to kind of show all the work, even though I did do a huge shrink on the first part, but make sure that you read all of it. It definitely helps to have your equation in standard form here. All right, that way you have your A value, your B value when we're dealing with the maximum. But whatever amount of questions I'm asking, please make sure you answer them all. All right, so this is where I'm going to go ahead and cut the video for this first part. You can already see the heading down at the bottom here for the second part. We're going to be finding inverses and range again, do a little review from notes 74. But this is the first part of note 75. As always, let me know if you have any questions or concerns, and I'll see you in the second part.